Well, I'll be damned. While China is proposing the largest dam project in the world on the Yarlung-Tsangpo River on the Tibetan Plateau, Europe and America are getting rid of dams. There are many projects on both sides of the Atlantic to remove outdated and unneeded dams across various rivers. The Klamath River Reclamation Project is the biggest so far, where 4 dams were removed in one go. The Kopko 1, Kopko 2, Iron Gate and J.C. Boyle dams blocked a 400-mile stretch of the Klamath River in Northern California and Oregon. Dave Meurer works for RES, who are performing the ecological restoration of the Lower Klamath project.
When your license comes up after 50 years, say, you suddenly have to comply with everything that Congress passed into law in the last 50 years. Suddenly issues like the Clean Water Act and the Endangered Species Act loomed large. So the owner of the facilities, Pacific Corp, did basically a cost-benefit analysis, and when they found out that they would be required to use fish passage over all the facilities, that cost alone drove them into a settlement agreement as opposed to relicensing.
These giant walls of earth and concrete stretched across the river. It's imposing, strong, and a symbol of human engineering in many ways. The dams were built to control water and provide electricity. Some were over a century old. How to remove the dams was a headache for the consulting engineers. Mort McMillen owns McMillen LLC, the company contracted with removing the 4 dams in the Klamath River.
What I've found is the best way to do it is go look at the way it was built and then reverse it. Typically on large dams, they move the river out of the dam footprint. It's usually through a tunnel, and then basically built the dam, and then they closed off the diversion and then put it in operation. And at the Klamath, that's exactly what we did. We reopened the old diversion works at 2 of the dams, and then basically on the 3rd dam, we put in a new low-level outlet by drilling and shooting up basically a tunnel at the bottom of the dam. Then opened those up, drained the reservoirs, got the water off of us, and then removed the dams.
The Klamath River dams are typical of the older infrastructure built when their far-reaching effect on the ecosystem was less understood. For millennia, dam building has been a way to harness the potential of water as a resource for power and irrigation. However, any blockage to the natural flow of a watercourse has an impact. Dams can block fish migration. Many fish species, like salmon, need to swim upstream to breed. Dams block their path and make it impossible for them to reach their spawning grounds, as on the Klamath River. This impacts entire ecosystems, as these fish are crucial food sources for other animals. Dams disrupt the natural flow of water. Rivers don't flow the way they used to. A dam alters the natural rhythm of a river, which can lead to lower water quality, changes in temperature, and destruction of habitats. Wetlands, forests, and floodplains that rely on the natural water flow are severely affected. Dams create a sediment buildup. Rivers carry sediments that provide nutrients downstream. Dams trap this sediment, preventing it from reaching the riverbanks and the deltas. Over time, this leads to a loss of fertile soil and impacts agriculture in surrounding areas. And, not least, dams have an impact on people. While dams provide power, water storage, and flood control, they also displace communities. Thousands of people have had to move because of the construction of dams, and these communities lost their land, homes, and sometimes even their way of life. It's easy to say, let's just tear down the dam, but the reality is much more complicated. It's not blown up in one go, like in the movies.
You don't just waltz in there and start using dynamite and big yellow machines. So Kiewit Infrastructure West did the dam removal. The hoops they had to go through were many. They had to make sure that it was seismically safe to take all the actions that they took. Draining the reservoirs had to be carefully controlled. So it was no small task. Once the permission was granted by the federal government, It was very expeditiously done.
Blowing a dam up, can we do that? Sure, but you can't control the impact to the river when you do that. All that material is going to go someplace, and typically it's going to go in the river. Then you can't get it back very easily. So it's really a controlled demolition, and you're taking it out of the river system and putting it in a safe location for disposal. Now, we did do a lot of blasting, like Copco 1. We drilled and shot all the concrete out of that. But like I said, we had it all controlled, kept it on the dam site, and then we excavated it out once we got a particular lift blasted and removed it.
Work to remove the 4 dams on the Klamath River began almost simultaneously. The smallest dam, Copco 2, was removed by October 2023, and the final and largest dam, Iron Gate, was disassembled a year later.
We had basically 2 years of construction to take the dams out. We had what we called our pre-drawdown year. And what that was for was to basically get all of our what we call low-level outlets ready to go so we can drain the reservoirs. The second year is the actual dam removal process. And we drew the reservoirs down in January, and we were done with construction and volitional passage through the dam footprints by the 1st of October. You know, the project started a long time ago. I would say active design and getting ready for it and permitting started in about 2018 as far as the construction documents itself. And then we were done in October of 24. So about 6 years, which is about how long it takes to build a big dam.
Getting rid of the millions of tons of material from the dams needed to be as carefully managed as the demolition.
It's primarily concrete. We actually had waste disposal sites or concrete disposal sites on each of the project sites. So identified areas that were permitted, they were designed in a particular way. We took all the concrete there, basically buried it, capped it, and then seeded it. On the earth fill part of it that was removed, like Iron Gate had over 1 million cubic yards of earth material in it. It was a clay core. We took it out, and we actually took it right back to where the material came from. So up on the left abutment of the dam, we put the access roads back in, transported it back up there, put it back into the hole, and then graded it and seeded it.
Although the Klamath River regeneration is the biggest dam removal project to date, work has also been going on in Europe. Herman Wanningen is the founder of Dam Removal Europe, a coalition of organizations looking to ease the removal of dams and restore natural habitats.
When I talk about dams, I talk about weirs, dams, small dams, big dams, but also culverts. We call them road dams. So there are all kinds of obstacles. And why we are removing them? Because when they get old, they need to be refurbished or removed. Because if you keep them there, they become dangerous. That's one reason. So safety is one reason. The other reason is when you remove dams, the water starts flowing again, the river comes back to life again, and there's migratory fish and all these other animals that use the river as their living place can thrive again, and then you get these abundancy back in the river.
Reducing river obstacles in Europe is a lot about redundancy and replenishing fish stocks to improve biodiversity.
There is this discussion in Europe about the biodiversity and the fact that we lost almost 90% of the fish stocks in Europe from the rivers. We have policies to bring that back. Dam removal is one of the measures to make that happen. Actually, the most effective measure.
According to Dam Removal Europe, hundreds of projects have been completed or are underway to free up watercourses. Europe's biggest dam removal project has probably been the twin dams on the Salmon River in Normandy, France. The dams were built in the 1920s and 30s, and costly work was needed to bring them up to modern standards.
It was a dam of 200 meters wide and 35 meters high, and it was just too expensive to refurbish it and to make it in compliance to the standards. So they decided, okay, we should remove it, and it was not really delivering too much energy for the grid.
The cost of removing the 2 dams and returning the river to its natural condition was around 70 million euros. Comparing that to the cost of removing the 4 Klamath dams at close to $500 million shows the difference in scale. The intention of removing the dams from the Klamath River was to allow salmon to return to the spawning grounds that had been unreachable for 100 years. Removing the dams had a short negative environmental impact, with some advantages.
There were millions of cubic yards of sediment and dead algae stored behind those reservoirs. So there was definitely an impact to water quality, for example. For limited periods of time, dissolved oxygen would crash, to like zero in some cases. There was a big die-off of non-native fish species, like perch, which frankly was considered a benefit because this was not a perch retention project with invasive fish that were planted. It was a salmon restoration effort.
However big a river obstacle may be, removing it creates a scar on the landscape, which needs time to heal. Those involved in Klamath are amazed at how quickly Mother Nature is recovering.
Our firm, RES, immediately began to replant and revegetate. Even as the reservoirs were being drained in January, crews were out broadcasting seed by hand. They were planting acorns, planting shrubs and trees. All told, there will be billions of native seeds planted, hundreds of thousands of plants and shrubs and plugs. So that work of restoring that footprint is ongoing, and that'll have a huge impact on the success of the project. We don't want it to just turn into a giant weed patch. We don't want it to be constantly eroding. So it's still kind of in process. But I talked with someone from the National Oceanic Atmospheric Administration, NOAA, who had told me prior to the removal of Iron Gate, he would have expected and hoped that fish would be back in Oregon within a dozen years. It took 2 weeks. Every biologist I talked to told me they were surprised by how rapidly fish made it, not only through the first and second, but all the way up into Oregon. Klamath fish are back in Oregon for the first time in a century, and it was stunning.
The success of Klamath is mirrored in hundreds of rivers across the United States and Europe. We will undoubtedly see more dams needing expensive refurbishment to meet modern standards. So the option for removal will become more economically viable, allowing our rivers to run smoothly and fish to return to their natural habitats.
Remember to hit the subscribe button and ring that bell to stay updated with our latest content. And while you're here, why not check out another one of our exciting videos? Thanks for watching, and see you in the next one.